So next, the given question is a differential equation. Okay, we have to determine whether the given differential equation is linear or non-linear. Okay, the question is d cube, third order differentiation of y with respect to t, d cube yt divided by dt cube plus 4 d square y of t divided by dt square plus 5 dy divided by dt plus yt is equal to x of t. Can anybody tell me what is the status of this equation, whether the linear or non-linear from your basic experience?
Linear, sir.
Yes, it is linear system because the higher order differentiations are allowed, okay, but the whole square is not allowed, okay, but here there is no whole square, but there are higher order differentiation up to order 3 that is allowed, that will not make the system non-linear. Okay, so this system is a linear system. Okay, this system is a linear system, but even though this is linear, okay, slightly I am going to modify my procedure. Okay, because so far we are applying this concept. Okay, what is this concept? A x1 of t, when I apply a x1 of t plus b x2 of t, okay, if I get a y1 of t plus b y1 of t, okay, when the input is like this, if the output is like that, then that system is linear. Okay, that means this is the equation that is representing both additivity as well as the homogeneity concept. Okay, when you apply the input like this, if your output is like this, then the given system is linear, or otherwise the given system is non-linear. Here the problem is, see, the y of t is the output, but the y of t is present in 4 places. One with the third order differentiation, another with the second order and first order, and directly y of t is present. So the output is little bit complex here. Okay, so far we are having output y of n, okay, is function of x of n. Okay, is function of x of n, or so far we are having the equation like this: y of t is function of x of t. Okay, so we are having the equations like this, but the now the equation is little bit different. Okay, there are so many y's. Okay, so there are so many output. Okay, the output is directly present, and also the differential format of the output is also present here. So when we try to apply this approach, okay, then this will be little bit tricky. So what we are going to do, okay, just I'm going to reverse the procedure. Okay, it's all just variable, whether you go from year to year or you come here to here, no problem. Okay, so both are same. So what I'm going to do, instead of going from year to year, I'm going to go from year to year. So what I'm trying to say is, okay, now what I will do, I will apply this procedure: a y1 of t plus a y2 of t, okay, that is equal to a x1 of t, okay, a x1 of t plus b x2 of t. Just I'm just reversing. Okay, nothing will change. Okay, no problem, both are same only. Okay, so I'll try this approach. Okay, so once if you are able to prove this, then the given equation is the linear equation. We can also do it in the other manner, then that will be somewhat complex. Okay, somewhat complex. Okay, so what I will do first, I'll try to calculate this one and this one. Okay, so because when it is in the opposite manner, when it is like this, we used to calculate y1 of t first. Okay, y1 of t first, next y2 of t, because just you can refer, I think, previous problem and all. First we will calculate this separately. Okay, then later we will apply this input as a combination, then we will try to get the overall answer. Okay, so now we'll just reverse. Okay, so now we'll try to get x1 of t first. Okay, then how you will get x1 of t? You can get x1 of t when you apply a y1 of t. What will be your, okay, if your output is like this, what could have been your input? Okay, your input could have been a x1 of t. Okay, if your output is a y1 of t, what could have been your input? A x1 of t. So just in the given equation, just you apply that condition. Okay, wherever y is there, replace with y1. Wherever x is there, replace with x1. Then I can write like this. Okay, d cube by dt cube a y1 of t plus 4 d square by dt square a y1 of t, okay, plus 5 d by dt a y1 of t okay, plus a y1 of t is equal to a x1 of t. Okay, it's very simple. Okay, so wherever y is there, put y1, and also along with a, that constant. Similarly, wherever x is there, put x1 along with that constant. Okay, a. So when I apply a y1, if the my output is a y1 of t, definitely my input could have been a x1 of t. So in this process, I am getting this one. Okay, I am getting this one. Similarly, I will try to get this one also. Okay, so then what I have to do? Okay, so a y2 of t. Okay, if you apply a y2 of t, then what could have been your input? Where input could have been a x2 of t. Okay, then d cube by dt cube b y2 of t plus 4 d square by dt square b y2 of t plus 5 d by dt b y2 of t, okay, plus a y2 of t is equal to b x2 of t. Okay, so in this process I got this x1 of t, a x1 of t and b x2 of t separately, because I applied this a y1 of t and a y2 of t separately. So next what I will do, I will apply both. Okay, in the same equation I will apply both a y1 of t as well as a y2 of t. Okay, wherever y is there, I will replace with this entire term. Similarly, wherever x is there, I will replace with this term. Whether if both are equal finally, then the given system is linear. Okay, so now what we are trying to prove. Okay, so next, okay, so now I will apply like this. Okay, a y1 of t, okay, a y1 of t is equal to b y2 of t, then that is same as a x1 of t plus b x2 of t. If you observe here, this a y1 of t, b y2 of t is the some new output. Okay, the combination of output, that output we used to call it as y3 of t. Okay, and again if the output is y3 of t, what could have been the input? X3 of t. X3 of t means what? Linear combination of the input. Okay, so okay, y3 of t means here x3 of t. So then from the equation, from the base equation, okay, now I will calculate x3 of t. Okay, x3 of t means instead of x I will put x3, and then instead of y I can put y3, but that is useless. But y3 of t is what? Y3 of t is this one, so I will put this one. Then finally I will try to prove. Okay, so next, the equation. Okay, first I'll write that equation. Okay, just I am modifying the original equation. Instead of x3 of t, this x of t was present in the right hand side, that I am bringing to the left hand side. Then whatever the term that were present at the left hand side, that I will write it here. So d cube by dt cube y3 of t. Now I will replace y3 of t later in the next step. Okay, next 4 d square divided by dt square y of t, but that is y3 of t, and then 5 d by dt y3 of t. Okay, then simply y3 of t. Okay, again we know instead of y3 of t we have to substitute this one. Okay, so then once if you substitute that, okay, d cube divided by dt cube, again this equation will be a little bit lengthy. Okay, so wherever y3 of t is there, you replace with that linear combination a y1 of t plus b y2 of t, and again this step 4 d square divided by dt square a y1 of t plus b y2 of t. Okay, and again this term plus 5 d by dt a y1 of t plus b y2 of t, and again the last step, this one. Okay, a y1 of t plus b y2 of t. Okay, so now what I will do now, just I will separate y1, you separate y1, okay, to one side, and y2 on other side. Okay, because each component consists of both y1 as well as y2. So you bring all the y1 components separately and the y2 components separately. Okay, so now I'll take all the y1 component, that means first component from the all the terms. Okay, from all these four terms I will take only the first component that consists of y12. Okay, so I'll write it in the next page. Okay, so if you try to segregate, you can take a d cube divided by dt cube, okay, y1 of t, okay, and 4a d square by dt square y1 of t, okay, plus 5a dy1 of t divided by dt plus a y1 of t, and then all the y2 terms separately. Okay, all the y2 terms separately, that is b d cube by dt cube y2t plus 4b d square by dt square y2t plus 5b dy2t divided by dt plus b y2t. Okay, if you carefully observe, okay, all this term consist of a, okay, then you write that a separately. But if you observe the rest of the element, okay, except a, okay, that will be resembling the original equation. But in the original equation y is there, here y1 is there, so you can simply replace. Okay, if you take a outside from all the component, remaining things you can just represent with the help of x1 of t, okay, with the help of x1 of t. Similarly, if we take b outside, this is resembling the original equation, but instead of y, here y2 is there, so that means what, here x2 of t. So what is our aim? Okay, we have to take the equation like this. Okay, if the output was like that, we have to prove that our input would have been this. Okay, so just we have proved that. Okay, so once if we take the output in this format, okay, here, because here you are applying that output, then definitely what could have been your input. Okay, where input is like this. Okay, so again it is satisfying the superposition principle. So this system is linear system. Okay, so directly also you can say, but in the exam we have to solve it, okay, with this procedure. Okay, again I have done it in different manner. You also try with going from like this to this. Okay, you try with some different way whether you are getting answer not or not. Okay, so next question. Next question, y of n is equal to a n square x of n plus bn x of n minus 2. Can anybody tell me what is the nature of the system? Is it linear or non-linear? A is constant, n is time index, x of n is the input signal, b is constant, n is the time index, x of n minus 2 is the delayed input. Okay, then what about the nature of the system? Is it linear or non-linear? Okay, so this system is linear system because there is no operation on x. Okay, and addition operation is there, but that will not affect the linearity. Okay, there is no operation on x, so that's why this system is linear. Okay, we'll try to prove. Okay, so when we take x1 of n as the input, then what will be the output? Output will be y1 of n. Okay, but if you apply x1 of n here, what would have been your output? Your y1 of n is equal to a n square. Then wherever x is there, replace with x1 of n. Okay, so this is x1 of n plus bn x1 of n minus 2. Okay, then if you apply x2 of n for the same system, then output will be y2 of n, that means a n square x2 of n plus bn x2 of n minus 2. Okay, so next what we have to do, we have to apply the new input, but that new input is the linear combination of the existing input. that is the new input x3 of n is equal to a x1 of n plus b x2 of n. But when I apply the new input x3 of n, my output is y3 of n. Okay, but y3 of n means wherever x is there, replace with x3. So a n square, okay, x3n, okay, x3n b x3 n minus 2, and again you are already having what is x3n. Okay, now you can replace your x3n with this equation. Here also x3n, but with the delay of minus 2. That means same equation with the, instead of n you have to write n minus 2. Okay, so first this is a n square. What is the value of x3n? That is a x1n plus b x2n. Okay, so here plus b x3 of n minus 2. You are having x3 of n, but we need x3 of n minus 2. That means a x1 n minus 2 plus yes, okay, plus b x2 n minus 2. Okay, now you just multiply this term a n square. Okay, you just multiply this term. Again we are making mistake somewhere, something is missing. y3 of n is equal to n square. This is a n square x1 okay, a n square. This is yes. Okay, so here in the original equation we are having bn, so that means here we will have bn. Okay, because in the original equation bn is there, so here also we will have bn. Okay, so now you just multiply this a n square inside, similarly this bn inside, then later we will try. Okay, we will try to segregate the terms. Okay, finally whether we are getting that linear combination of the output or not. We applied the linear combination of the input. Okay, we will try to adjust the equation. Finally if we get the linear combination of the output, okay, because that y3 should be the linear combination of the existing output. If that is in that manner, then finally this system is linear. Now just you take this term inside and just multiply. Similarly this term inside and multiply. Okay, so we'll be getting this one, a square n square x1 of n plus n square ab x2 of n plus ab n x1 of n minus 2, okay, plus b square n x2 of n minus 2. Okay, we'll get 4 terms. Okay, from these 4 terms you try to segregate the x1 terms separately, because we finally try to write in terms of y1 of n and y2 of n. y1 of n consists of only x1. Okay, that means x1 of n and x1 of n minus 2. So try to take try to separate the x1 terms separately. Okay, try to adjust. Okay, so now if you take if you concentrate here x1 is there, here x1 is there. From this I can take a is common, I can take a. Okay, then what is the rest of the term? A n square x1 n plus here bn x1 n minus 2. Okay, and similarly in the rest of the term, from this term you can take b outside, because here also b is there, here also b is there. If you take b outside, then write the rest of the terms. So if you take b outside, then a n square x2 n plus bn x2 of n minus 2. Okay, if you compare, okay, this one, this entire term, this is something similar to y1 of n. Okay, what is y1 of n? A n square x1 of n. Okay, a n square x1 of n, and then bn x1 n minus 2. Okay, bn x1 n minus 2. So that means what? Instead of this I can write y1 of n. Okay, similarly here instead of this term, that will be definitely equal to y2 of n, this term. Okay, so y2 of n. So when I apply the linear combination of the input, okay, I am applying the new input, but that new input is the linear combination of the existing output. Now I am getting some output, new output. That new output is the linear combination of the existing output. So if it follows this condition, then okay, it is following the superposition principle. So this system is linear system. Okay, this system is linear system. So far we are discussing about around 10 problems. Out of this, something is linear, and almost half of the problems are linear, and rest of the problems are non-linear. Okay, finally we'll try to write all the problems in a single page, then we'll compare, okay, how the system goes to non-linear state, why some systems behaving as linear, some other systems are behaving in a non-linear fashion. Okay, we'll just see, we'll compare. Okay, conclusion. Okay, so what about the first system, yt is equal to t x of t? Can anybody say what is the system, linear or non-linear? What about the second system? Okay, these are all the system that we have already discussed. Yes, tell me quickly, what about the nature of this system? Is it linear or non-linear? First system.
Linear, sir.
Linear. Okay, linear. What about the next system? Non-linear.
Non-linear, sir.
Linear. Non-linear. Log x of n is linear or non-linear?
Non-linear.
Non-linear. Root xn, non-linear. X of n into x of n minus 1, non-linear. Linear. 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 Okay, so what is the observation here? First equation, if you see, even though the t is present, this is not making the system to be non-linear. Still the system is linear. So to determine whether the given system is linear or not, you have to concentrate on x of t. Only you have to concentrate on the x of t, because the linearity concept is purely related. It is purely related. It is the pure relationship between only input and output. Okay, so what is input? Okay, you have to observe what is the input, what is the output, whether is there any operation is there on input, that you have to observe. Again, even though the time is there, that will not affect the linearity of the system. Okay, let it be t or t square or any other t value, t minus 1 or t plus 1, that will not affect the linearity of the system. So that is the first idea. So but whereas in the next case, okay, t is not there, but just you are making the square. Okay, so x square, that means you are making the input. Okay, x of t is like a input, you are squaring the input. So that will make the system non-linear, because already you know whenever square is there, that is like non-linear. Okay, but whereas in the third case, if you see, here also square is there, but that square is not for the signal, that square is for the time. Okay, and just now I told you, you do any operation on time, that will not affect the linearity of the system, but if you do any operation on x, that will affect the linearity of the system. So in this case, definitely this t square will not affect the linearity of the system. The system is linear only. Okay, the system is linear. Okay, so let it be t square or t cube or square root of t, whatever it may be. Okay, any operation on time will not affect the linearity of the system. That is the first idea. Again, the fourth question, y of t is equal to 2x of t plus 4, and you know the presence of constant will make the system non-linear. Whenever the system is like system equation is something similar to line equation, this is something similar to line equation, y is equal to mx plus c. If the constant is there, the presence of constant will make the system non-linear. Okay, that means the line will not go through the origin, then definitely the system is non-linear system. Then the next question, y of n is equal to log of x, and again you see here this log operation is applied for x of n. Okay, x of n is the input, the log operation is applied on x of n. Okay, already we know log is by nature it is a non-linear one. By nature log is a non-linear term, and that too you are applying that log here for x of n, so definitely that will make the system non-linear. Suppose for example if you are applying log like this, say for example instead of t log t x of t, again the system will remain linear only. You are applying log, even though the log is non-linear quantity, that log you are not applying to the signal, you are applying to the time. Okay, that will not affect the linearity of the system, but here the log is applied to input, okay, x of n, so the system is non-linear. System is non-linear. Even sometimes they used to give like this also, instead of log they used to give sine x of n like that. Okay, again this is also non-linear only. Sine by nature it is non-linear, that to applied to the input, again this is non-linear only. Even if you are not convinced with this, you can go by ordinary procedure and you can prove sine x of n is also non-linear quantity. Okay, so next, y of n is equal to square root of xn. Again already you know square and square root are opposite to each other. If square is the nonlinear quantity, square root is also nonlinear quantity. That too, that square root you are applying to the signal. Okay, that means what signal means, that to input, specifically for input you are applying. Okay, so definitely it will make the system non-linear. The next case, y of n is equal to x of n into x of minus 1. If it is x of n whole square or x square of x of n or x of n whole square, both are same. Okay, if the case is like this, definitely this is non-linear, but this is also something similar to this one, but with the delayed operation. Okay, so again this is also a non-linear system. Okay, this is also something equivalent to square only, but with the delayed operation. And then eighth system is purely a linear system, because here there is no multiplication operation, only addition operation is there. In general, that addition is the linear term only. Okay, the addition will not make the system non-linear, and again there is no any specific operation applied on the signal, any extra operation like square root, square and all not applied here. So definitely this system will be like a linear system. And also one more thing is, here there is no constant. If the constant is there, the system could have been non-linear, but here there is no constant, all are signals only, so that's why this is a linear system. And already you know, whenever the differential equation is given, okay, higher order differentiations and all allowed, but that overall square is not allowed. If the overall square is present anywhere on this equation, then definitely that will make the system non-linear. It could be here for input, or it could be for output or differentiation of output. If overall square is there, that will make the system non-linear, but that higher order differentiation and all will not make the system non-linear. Okay, the system will be in a linear only. Okay, so the final one, a n square x of n plus b x n minus 2. Here if you see here n square, okay, n means time index. Okay, you apply any operation on n, no problem, that will not affect the linearity of the system. Okay, so again just you are adding the two signal, and also there is no constant, so definitely this system is also a linear system. Okay, so then what is the conclusion finally? Okay, what is the conclusion? Any operation on time will not affect the linearity of the system. That is the first idea. Any operation on time will not affect linearity of the system, will not affect linearity of the system. Okay, I am not saying the system is linear. Okay, that will not affect the linearity. Again, you have to check some other condition also. Okay, so any operation on time, it will not affect the linearity of the system. That means what? If already the system is linear, then it will be linear, or otherwise if some other operation is making the system non-linear, then system is non-linear. Just because there is operation on time, you cannot say directly that system is linear one. So that's why I am giving the statement like this. Okay, any operation on time will not affect the linearity of the system. Okay, and the next, presence of constant will make the system non-linear. Presence of constant will make system linear, will make system non-linear. Okay, third one, operation on signal amplitude will affect the linearity of the system. Okay, operation on signal amplitude will affect linearity of the system. That is, it may make the system non-linear. So what is the example? Suppose y of t is equal to, if you are writing x square of means, so square you are applying to the amplitude. Okay, so that's why this will become non-linear. Or otherwise, if you are writing like this, square root of x of t, square root means square root you are taking for our amplitude. Okay, so you are applying operation on signal amplitude, then that will affect the linearity of the system, and that too square root, square and all, definitely non-linear. So it may make the system non-linear. Okay, and fourth one, square operation is generally non-linear, that we know. Okay, square operation is generally non-linear. Similarly, delayed square operation is also non-linear. Delayed square operation also non-linear. Okay, just now we have seen the example. Okay, that means y of n is equal to, if it is given like this, x of n, x of minus 2, again this is the non-linear. Okay, sometimes they used to give like this also. Okay, x of n, and they used to give like this, x1 of n into x2 of n, something like that. Okay, again that is also a non-linear one. So just a product. Okay, the product will make the system generally non-linear. Okay, so the delayed square is also a non-linear system. Okay, so we will stop.